Fonts, on the other hand, are the richest possible designator for the appearance that can be given to text characters on a screen or a device. They are requested from the system by an application. At the time of the request, an application fills in an entire data record specifying exactly what it wants. It says, what I really want is Helvetica at 14 point in bold and italic. What it gets may be something less than that, depending on what the system is capable of providing based on the data which are available at the time and the number of installed fonts. But the intention of the font system is to allow applications to become truly independent of the available set of fonts and to let the system do the choice of what fits best the request which was made. At the time a font is created or selected by an application, its attributes may be made frozen, in which case no subsequent calls to change the style or the size or the width will have any effect on the font, or it may be made changeable. That is often a decision made by the font designer at the time the font is created and vended to users who place them on their systems. The functionality provided with fonts has to do, first of all, with loading them up. Often, for example, if you buy a font from a vendor and that font consists of outlines which can be made to look good on devices with various different resolutions, the device vendor will include an application that loads up the font. If your application has created font definitions that it wants to load up, the calls to load and unload font are there to make a font a system-wide resource for later discovery when fonts are selected by an application. If an application wishes to find out what fonts are currently available in a system, it can inquire what those fonts are, and it gets information about all of the Helvetica styles that are available. It returns one at a time, and you can go on inquiring until the system has exhaustively enumerated all of the font types that it has available. Functions available with reference to symbol sets. Recall, an application provides all the data with reference to a symbol set, and a particular symbol set is available only from within a particular presentation space. Are to load a symbol set, where you provide the name that it will be known by, and potentially the length of the data and a buffer in which all that data is kept. You are returned an LCID, a logical character set identifier, which is how an application would later on choose to use a particular loaded symbol set. When you're done with it, you can delete it. You can find out how many are currently installed by asking. You can find out what the types of symbol sets are, whether they're, for example, whether their character data is bitmap or whether their character data is glyphs or stroke sets or what have you. And you can actually get the data for any number of characters that you want out of a symbol set. That's in case you created it earlier and you forgot. When it comes to creating a logical font, what you do is to pass in a whole lot of parameters that specify the characteristics that you desire. The system then goes through a process of trying to match your request with available fonts. Now in video, what we can see here is that in this case we've got a test font which has been requested in a certain style. If we were to change, currently we're looking at the system version, that is the system font version of that character string. If we were to change our interest to, say, select the Helvetica version of a font, what we'd find is the system would go out. It would take the same request for a font in terms of size and so forth. All we've done is to change the requested typeface, and we get a different set of characters. Again, if we were to change to something like the Roman form of the characters, what we would here get is a set of characters stroked out as actual a sequence of vectors and drawn as polylines in this particular system. In any case, we could now begin to synthesize attributes. We could say, well, okay, fine, you've given me the Roman form. Now what I'd like is to see that in italics. And the system would then go back. It would create a new font and return to us that font, and we would redraw the character set. We could take the italics and now go back and change the system, the font. So perhaps if I wanted to go now to the Helvetica form, I can now get a Helvetica italic version of a font. Each of those changes was associated with a create logical font based on my menu choices here and then the system's returning a new selection on its part of the available font. You notice that while I didn't change the specifier for the size of the font that I wanted at all, the system in each case returned to me a slightly different looking length of font. That has to do with the low resolution, the number of bitmaps I have available to actually use to create images of character texts on the screen and so forth. But all of that has to do with the system's matching a request for a logical font to the available images in the system. When I'm done with a logical font, I can delete it and make it go away. If I want to find out what the system has actually done after I create a logical font, I can then query the metrics of that font. I can say, okay, I asked for Helvetica, rotated 14 degrees and in bold. What did I get? And with the query font metrics function, I might find out that, well, what I really got was Courier, which is not, in fact, proportionally spaced, but fixed pitch. And by the way, I didn't have 14 points, so I chose 12. And I couldn't give you italics, so I didn't, and so forth. The font metrics query then returns to you information about exactly what is the font that the system has selected. And this is what allows me to optimize my use of the fonts available, say, for display, which tend to be fewer in number, for what I know that I could do on a printer. And it allows me to do what I like to call incremental WYSIWYG. That is, I may find out that a printer can do a really good job of 14-point bold italic Helvetica, but that the display is going to do a lousy job and is in fact going to give me Courier. Using the font metrics, I can make sure that my Courier text string occupies almost the same space that the actual Helvetica bold italic string would occupy on the printer later on. And that's what gives me WYSIWYG. I like to think of it as printer-centered WYSIWYG, because for the moment, printers have a lot more fonts than displays. Ultimately, of course, with the wide provision of font logic and font capabilities, displays will begin to do a better and better job of matching. And any functionality that your application has which does the matching, stretching and shrinking of strings will gradually vanish because you'll get more and more like what you wanted from the display, for example. In any case, when you're done creating a font, you may want to find out what the width table is. Particularly in the case of proportional fonts, any integer round-off for purposes of creating bitmap images for characters to be used on the screen is going to result in changes in the widths of those characters from the ideal. And our font mapper is the construct that actually does the selecting. In order to give you some control over the way in which weights are applied, for example, do you care more about the typeface than you care about the type size? Do you care more about the width or the proportionality of a font than you care about the character set, and so forth? The mapper weights are inquirable and settable by you. This is a new thing which was not present in the Microsoft GDI. We've also added a number of other functions which currently exist only as escape functions within Microsoft Windows GDI. For Microsoft's OS/2 Windows Presentation Manager, we have made those functions actual calls in the API. You can turn on kerning or find out whether it's on. Pair kerning involves the movement of characters together, that I sneaks in underneath a capital W, for example. And you can find out what pairs will be kerned and how much. You can find out what those pairs are, and so forth. Track kerning has to do with the fact that at larger and larger sizes of font, you want to actually move a character. You want to move that I in further underneath the W if it's a very large W than you do if it's a very tiny W. And in fact, if it's a 4-point font, which is almost infinitesimal, you may not want to kern at all. Track kerning has to do with the nature and the shape of the curve applied to the nominal values of kerning. Those are all the functions that relate to the font per se. Now, in addition to the font, there are a number of functions which relate to trying to change the appearance of the character set once it's been selected. These include functions to change the character set, specifying simply which logical character identifier you want to use, and pulls in either a symbol set or a font. In either case, depending on which logical character set you're currently using, you may want to change the character box size. On the video, we can show you here that the change in size is going to, of course, be mapped to whatever sizes are available. but that as you change the character box, you may get different sizes of font. In fact, sometimes we'll synthesize. Here you can see that we've taken a smaller image and blown up some of its pixels in order to get an image which is close to the size that you've asked for. That's a function of the underlying font capabilities, and the system will do the best it can to render a character box near to the size you've asked for. Other character functions are provided to allow you to set the angle at which a string is drawn. This, for example, allows you to draw text at a non-horizontal baseline. You can change the shear. This is to do with the creation of italic characters of a character set. You can also align a text string either horizontally or vertically. We give you a number of control points at which to align the character both horizontally and vertically, an incredibly rich set. And in particular, the ones that are of interest often are the center and the half alignments, which allow you to center a text string on the current location. In order to support the drawing of text, which is labels for axes, for example, on a graph, or to support text which is written in foreign languages, we provide a text character direction, otherwise known in other graphics languages as text character path. Here, the image at the left of text from left to right is the standard English way to draw characters. From top to bottom, which is the next from the left, it would be a way to label axes. The next one over right to left would be useful in languages like Arabic, which are written in that direction. And finally, from bottom to top would be useful in languages that I haven't even had a clue of. But they also relate to the way in which you might want to create labels for slides. It turns out sometimes that it's useful to run things backwards so that they appear frontwards in the way that they're actually imaged on a device. Notice that the character direction does not turn the images around. The E in the third image from the left is still an E which faces rightwards. What we have done is to change the direction and the order in which text is laid down as individual characters. You can set the text mode. This controls how carefully the system is supposed to image a font that you may have described which is particularly strange and has a lot of complex attributes that need to be synthesized. You can say, well, okay, just get the origin correct. I really am just going to do sort of a proof of this picture, if you will. You could specify that you want each of the character origins to be exact. Or finally, you can say, okay, you better get everything correct. Clearly, the character mode is going to have an impact on the amount of time the system has to spend to image a character sequence. You can set the spacing using a fixed point multiplier to change the spacing of characters. You can add spacing in the event, for example, that the font you get is not quite the right size and you want to do WYSIWYG. The text character extra allows you to add or to shrink the spaces between characters and effectively is a multiplier or a fixed offset in the width table for each character. This allows you, for example, in the event the system has mapped onto a font which is a little too big, you can shrink it up so that your characters may be too close in terms of real WYSIWYG, but the overall appearance is of the correct length in the setting of the text strings that you want to image. When you're through setting up the text spaces or changing the incremental distance between characters in the string, you may want to actually change the size of spaces. That's the text break extra. You specify which index is the break character and you add or subtract spaces in that area. Finally, when you set up all the attributes of both fonts and characters, you might actually want to use them, and you might want to place a text string at a location using the current position or providing a new position. Basically, you choose the text char string or the text char string at, and give us the number of characters and a buffer filled with the indexes for those characters. There are two more functions, both of which, again, either consume current position, which the GPI char string pos does, or don't consume current position, as GPI char string pos at doesn't. The other parameters here, in addition to the n and the buffer of character indexes, which is to make up the character string, include options. and an additional xy parameter, and finally a dx. These text character string primitives, functions, are used, they're incredibly overloaded. And they're used, for example, to say, well, gosh, alrighty, take the background rectangle that I've got here and change it to a pattern and then put the text down. You may specify an actual character origin location per character if you wish. You can de-emphasize the string to, say, unhighlight it, as, for example, in a de-emphasized menu item or an unselectable menu item. And you can choose whether or not to leave the current position alone. I'm fond of saying that for those of you who like parameter overloading in the GPI subsystem, we don't do a lot of that, but here it is for you. The use of the options parameter, the XY, and the DX allows you a tremendous amount of flexibility in the way in which character strings are actually imaged onto the target device. Those are the set of functions which relate to the imaging of text on devices. The GPI function set is richer than any other I know of in this setting. There's a lot to it. Tremendous amount of control is provided for you to actually create near WYSIWYG kinds of performance with the GPI. There's a lot to be studied there. You can get out your favorite graphics design handbook. You could get out any book on typography or type design or take courses in it. You will find that the system is sufficiently rich to support all of your explorations in the use of better and better near typographical style text with the GPI. Finally, I want to look at the function group that would allow you to capture images once you've created them. GPI's Metafile system allows you to acquire portable pictures and to ship them around from one place in a system to another. Metafiles are created in a special device context known as a Metafile DC. They may be transiently stored in random access memory and permanently stored in RAM or on disk. In order to create a Metafile, you have to create a presentation space, open a Metafile DC, associate the two, do a bunch of drawing into that presentation space, close the DC, and then move the Metafile onto a disk for safekeeping and later reuse. There are a number of functions in the setting, in the GPI function set, to support your use of metafiles you save. For example, you can load one, you can copy one from one place to another. If you want to restore or use a metafile to draw onto a device, you can play a metafile onto a presentation space, and when you're done with it, you can delete it out of RAM. The delete metafile function does not delete any file associated with a metafile. It is only for use with deleting in-memory metafile handles. If you want to save one, you can find out how long it is. You can get its bits into a buffer that's in your address space, or you can take it from an area in your address space and put it out there for future use. We've just finished looking at the final set of functionality in the GPI. These functions are those which embody the control over raster images, those which are point sample intensity or arrays of colors or integer values at locations. The rich set of combinations and conversions, both spatially and in depth of color in the raster primitive set for GPI is unmatched in any other system. It requires a lot of study to get a handle on it, but it is designed to allow you to control the use of the CPU time for resampling and restoring and the changing of images as you move them from one place to another. We've taken a look at the functions which are embodied in the text primitives for GPI. These are the functions that allow you to get arbitrarily close to doing WYSIWYG. What you see is what you get, type of text imaging on the devices that are attached to presentation spaces your application may be using. We've seen how fonts may be requested from the system, which will do the best it can to match the requested font, and how symbol sets may be asserted, that is, provided by your application to the underlying presentation space. And finally, we've taken a look at a few of the functions involved with saving and restoring sequences of picture elements in metafiles for use in portation from one system to another. This has been a fairly long dissertation on the functionality in GPI, but by now you've been exposed to virtually everything that's in it. There are a lot of new concepts, there are a lot of places to go that you can learn to begin to understand how these constructs can be used by you to create images on screen and on presentation devices which help the humans who buy your applications to use the systems more and more accurately and adequately. I think you'll find that the more you study, the more capability that you'll find within the GPI instruction set. Those of you who are familiar with Microsoft Windows GDI instruction set will recognize a great deal of the underlying functionality. Those of you familiar with the advanced instruction sets embodied in many of the printed standards will find that what we have done in the creation of the GPI for OS/2 is to extend our understanding of graphics into a much richer realm. I think you'll find it an extraordinary new world into which you can move and write incrementally more useful applications. Thanks for your time and attention. Good hunting with the GPI instruction set.
For additional information on the topic we just covered, be sure to take a look at the written questions and answers that accompanied this videotape.